CO2. I know what I'll do. I'll create a sealed flowering room and we'll eject the carbon. Where does the carbon come from? It's stored in a transient pool of carbon in the form of organic acids that happen to be oxidized and released directly to the active site of rubisco. So again, we see this in CAM plants distinctly, and we see this with C4 plants distinctly, and somehow most people overlook what happens in C3 plants, which is that thylakoidal carbonic anhydrase mechanism that I mentioned earlier, where the plants oxidize bicarbonate and release ATP, NADPH, CO2 all to the Calvin cycle. So they balance the intensity of the electron transport chain with the carboxylation potential of the Calvin cycle. And if there's excess power supplied, they go through the oxygenation reaction, which, by the way, converts and allows for CO2 to be delivered back to rubisco, therefore creating a closed loop, and creates reduction power to take nitrate out of the soil and make amino acids, which explains why C3 plants like cannabis can take up high concentrations of nitrates. They're hardwired to take up nitrates. Cannabis plants love nitrates. They're hard, that is in their, baked into their DNA. They need nitrates. It's part of their bloodstream. In fact, if you give them amino acids, if you give your cannabis plants amino acids, they'll oxidize those amino acids, convert them into nitrates, take up the nitrates, and then process them back into amino acids. They love it.
Hey, Nick, can we drill down into nitrate reduction a little bit or on that subject, since you led right into it?
Yeah, it's a complex process metabolically for plants. It's very expensive for them. It can take like 25% of the overall power that's created through photosynthesis, but nitrogen only makes up maybe 3 to 5% of the overall biomass of plants. So the problem here is like there's a major energy sink associated with a small concentration of biomass. And this helps explain why we typically don't see nitrogen at the active site of a lot of these enzymes. When we're talking about enzymes and the things that enzymes do, like make the terpenes and make the cannabinoids, nitrogen is not involved at the active site. It's more of these micronutrients, these trace elements. Nitrogen is required in large quantities to build the structures. It's like kind of like an engine mount for an engine. It's not the thing that actually fires and produces the torque and produces the horsepower. But if you don't have the proper engine mount, you can't harvest the power and convert it into something useful, right? So when we're looking at nitrogen in the context of chlorophyll, it's literally just like an engine mount. Chlorophyll is this engine that runs on the spark, air, and fuel, just like a car engine, right? And without the proper engine mount, the power is destructive. It's not constructive for the plants. So